Okay, so my big secret, and I'm sure nobody will ever know, is that I started life as an accountant. I went in as business development manager from a finance background. So I corrected that error of the first 20 years of my working life by pursuing a master's in GIS and remote sensing.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Tom McHugh. He is the CEO and founder of the Icon Group. And they're doing some really interesting research around developing a methodology to do an animal inventory using Earth observation remote sensing. So this podcast episode was inspired by an article that I read in the Journal of Remote Sensing in Ecology and Conservation, and this was all about using high-resolution satellite imagery and deep learning to detect and count African elephants. And I thought this was a really, really interesting use case. So when I went looking for someone who perhaps could help sort of walk us through what this process might look like, I discovered Tom, I discovered Icon, and I thought there was a reasonable amount of overlap between what this journal article was suggesting or the methodology that they'd used and what Tom and his team were doing. So I really hope you enjoy this. Once again, Tom McHugh, CEO and founder of the Icon Group, and today on the podcast we're going to be talking about using satellite imagery to count livestock. Hey Tom, welcome to the podcast. Today we're going to be talking about Earth observation, and we're going to try and sort of attach that to animal tracking, to doing a livestock inventory. And I think before we get started on that side of the conversation, perhaps you could just introduce yourself to the audience and maybe explain how you got involved in the Earth observation industry.
Thanks, Daniel. I'm Tom McHugh. I'm CEO of Icon, a Dublin, Ireland-based Earth observation company. And it all started out accidentally, as most things do. I went in as a business development manager to a young campus company that had started making maps from satellite imagery. And basically, the image was a background, and it was new, it was innovative. And they were also using satellite imagery to aid in the exploration for precious metals. I came from the candy business, so this was literally a kind of a earth-shattering for me. I thought it was fascinating. I thought it was incredibly interesting. And after a stint with them of about 4 or 5 years, I started Icon. And I'm still with Icon 27 years later.
So just so I've understood this correctly, you started off as an accountant and moved into the Earth observation industry.
I did. Okay, so my big secret, and I'm sure nobody will ever know, is that I started life as an accountant. I went in as business development manager from a finance background. So I corrected that error of the first 20 years of my working life by pursuing a master's in GIS and remote sensing. So I hope I've atoned for my earlier sins, and that's what's brought me to where I am today.
Well, Tom, I want you to know that your secret is absolutely safe with me. I'm not going to tell anyone about that.
Good.
So as promised earlier, we're going to try and tie this into animal tracking. What does Earth observation have to do with animal tracking? How does that tie in?
The resolution that's available now in commercially available imagery goes down to 30 centimeters. And with modern interpolation techniques, you can produce images with a 15 centimeter resolution equivalent. So that brings in the possibility of being able to identify features in pastures that would have otherwise not been visible. So being able to count livestock is quite important on a number of different levels for animal disease control, for inventory purposes per se, and then also to get a view of what's happening with the land, the cultivated land. Is it being cultivated for pasture, which is a form of cultivation, or is it in arable crops?
Okay, so it sounds like we've got a few different things going on there. We've got the use of Earth observation data to count objects, so to find animals and identify animals. And we've got this high resolution imagery that you're talking about, but you're also talking about something else, or at least for me, it's something else. I think you're talking about the classification of ground cover. Am I right so far?
Yes, that's actually our main business, is the classification of land cover into categories that are of interest to our client. We do a lot of work in support of agricultural subsidies, in the validation of subsidy claims, also in looking at environmental degradation. Say, for example, if there are nutrient problems with forestry or with habitats as well, is the habitat being eroded, invaded? Is the vegetation in the habitat under stress? All of those issues. They're questions that really more and more need to be answered.
Yeah, I completely agree. And I think a lot of the listeners will be really familiar with those sort of use cases. But if we come back to this animal or livestock inventory, you mentioned before that we've got this real high resolution satellite imagery. Would you mind just telling me again what those resolutions are and if it's optical imagery that you're using or is this multispectral?
It's multispectral optical imagery, and it can have up to seven different bands. The spectrum of light broken up into seven different bands. So essentially, what an optical sensor is doing is measuring the reflectance of the sun's light from the Earth. And if that's broken up into different parts of the spectrum, you can analyze them separately, and by using different band combinations, you can produce a great variety of information sets from the data. Just as you mentioned non-optical image sets, we also, because of the areas in which we work, we also work with radar data, which is a different product entirely in that it is the measurement of a signal that is sent out by the spacecraft, a radio signal, and its return is measured. It tells you entirely different things, but equally useful.
Are you using both those sources for when you do this animal tracking, when you're identifying animals on pasture land?
No, we're using the optical imagery. So, in essence, we're looking at the pixels that represent the image of a cow, as seen from a great height. I mean, some satellites are orbiting the Earth at 700 kilometers distance, which is quite some way. It's measuring the spectral signature of, let's take the example of a cow, the spectral signature of a cow, in contrast to its surrounding area. So, in a perfect world, they would all be on snooker tables with good, clean grass underneath, and they'd stand out perfectly well. But unfortunately, the real world isn't like that. And we have to make adjustments for uneven pasture, scrub, rocks, and things like that, which would give us, say, the rocks particularly, would give us false positives. It's just that if the cow hasn't moved in 3 months, we've a good idea it might be a rock.
I was going to ask about things like that, how you ground truth this. So is it a matter of taking an image and then going out to the field, as soon as possible and seeing how many cows are in that field, or is there another way of doing that, of testing your results?
There is, happily, because this research has been carried out in the European Union, there's a good inventory kept by the responsible authorities as to who's got what cows. So, as you probably know, they're all ear tagged, and at any moment it's possible to determine what a herd keeper has as an inventory. What's not possible from the ear tag based track and trace for food security, what's not possible to do is to say where he has them. And quite often, farms are spread out in ways that we wouldn't necessarily think of. I mean, they're spread out in places like Australia and in Canada and the US because they're big. But in Europe, they're spread out because there might be a cluster of land parcels in one area, and then at some distance, there might be another. This exercise is to see if we can match what we've observed at a point in time with what the farmer is recorded as having by way of livestock. And then we're adding the extra dimension, which is always important in geography, where.
Could you just explain to me why that where is important? Because I'm assuming if you have a number already through this sort of ear tag system that we have in the European Union or in Europe in general, what extra dimension does that where add to it, and why is that important?
Say, if you take my home country, Ireland, approximately 8,000 farms have a spread of more than 32 kilometres. And the average number of clusters of parcels is three. So if there's an outbreak of what's called a notifiable disease, and the one that we might all know, and those of us who are older might remember the outbreak of foot and mouth in Europe in 2000 to 2001. It's a very, very virulent disease that's airborne, and it's important that action is taken very quickly. So if you send a team of vets out to basically start testing and isolating, and they go to the wrong part, they go to an area where there are no animals, then that's going to cause a delay. So it's important to know where they are at any point in time and to be able to, I suppose, direct any activity that's required to the right area.
So we talked a little bit about the data that you're using. You mentioned that you're basing your research on optical data and you're looking for the spectral signature of, let's say, for example, cows. Once you identify those cows, can you determine the shape, size, if it's healthy, if it's sick, that kind of thing? Or could you say, hey, I've seen that cow before? Is there any other attributes you can calculate about identified animals?
What we're looking at doing as a sidebar module is cow type species. Not well, they're all one species, but basically breed. So they're common breeds that we'd see them as black and white cows, or we'd see them as brown cows. And farmers tend to have a particular breed for a particular purpose. So that in itself is useful intel, if you like, or useful information. Another, I suppose, challenge in a way is to see if the cow is a mother, and because we're also working with sheep, to see if the sheep is a mother. So we're going to get, even with young lambs, we're going to get a slight difference in the pixel count if the ewe is feeding a lamb, or minding a lamb, or rearing a lamb.
Okay, simply because that sort of blob that you will see in the image is going to be slightly bigger because there'll be a lamb close to it. Is that the way to understand it?
Yeah, it is indeed. It is indeed. And, it's determinable which side of the animal that the lamb is on. So you will see some of them on the left hand side and some of them on the right hand side, but generally so close by, it's a measurable entity.
Wow, that's pretty amazing. It's pretty detailed. Do you look for other things too? Like, can you say, okay, I can see the tracks of animals going into this field. Do you look around objects as well to try and confirm that your identification, your classification is correct?
That's a really good question. And yes, we do. So there are some features in farming, particularly in temperate climates, where you get what's known as poaching, which is where the animals gather around maybe a water trough or at the edge of the field, where they come in the morning if they're housed at night time. And so that leads to the churn of the vegetation cover, and you end up with exposed earth. And that's not necessarily a good sign or a bad sign, but in context, it tells you something else. For instance, if there are no cows in the field and you could see evidence of the poaching, it's an indication that the field is being actively farmed.
You mentioned right at the start that you have this background in doing land cover classification. So I guess you can use your abilities in that area as well to develop context around these other objects that you're seeing. Can you pull in different data sets as well? Could you use something like, I don't know, European wide weather data sets? Would that be relevant? Are there other kinds of easily available data sets you can use in your classification or use to help derive these kind of other data sets?
That's a really hot topic for us at the moment, particularly the meteorological data. And we're moving towards, I mean, essentially in mapping now, we speak of the skin of the earth. And it's the same for imagery, because if you get an image where you are interested in certain features, you also get the features that surround it, the feature of interest. And that means that you then have contextual information. Meteorological data is important because you can have two fields of exactly the same size with exactly the same types of soil, but one of them gets rained on every day and the other one doesn't. And then also sun angle, is it north facing? Is it south facing? In the northern hemisphere, that can make a difference, particularly for, I won't say extreme slopes, but noticeable slopes. So all of the information that we can get, we tend to use. And that sounds like a general statement, but more and more we find that soil types, meteorological data, history is equally important. So you look at a situation today, you make a decision. Then if you can look back through the archive of imagery, you may be able to fine tune that decision. So you can see, maybe perhaps if there's a problem there, you can see when it started, you can see whereabouts in the feature of interest it started. And so you're able to give a much better, what shall we say, analysis of a situation to somebody who's looking at this as a problem.
Yeah, so I can completely understand that idea of going back into the archive, running similar analysis, and then trying to determine change over time to how we got to where we are today. What about going forward? Is there any evidence that suggests that methods like this will help us make better predictions about what's happening in the future?
I think so. I mean, there are huge changes taking place in the ability to process data, in the ability to store data, and they're having a very big impact on the Earth observation industry. Another change that's taking place, and it's interesting to see how it's parallel changes in different domains coming together. That's really what brings about positive improvement. The cost of launching a satellite is changing. It used to be a big couple of ton of metal thing that got launched almost exclusively by NASA. But now they're with the CubeSats, they can be just a couple of kilos, and they're still able to send back data from space as good as the larger satellites.
I want to stay with that for a second because in the pre-interview you mentioned this idea that we were going to see space platforms not just being sort of the housing for sensors, but also in terms of having applications on them as well. So being platforms for these sensors, but platforms for applications. And I'm sure that you talked about a chip that was going to be installed or was installed on some particular satellite platforms that was going to determine cloud cover. Would you mind walking me through that example again, please?
Yeah, somebody gave me a statistic about 4 or 5 years ago that 78% of optical data was not being used because when it was downloaded, it was shown to be cloud occluded, which means that the cloud was covering part or all of the area of interest. And there have been some technical changes to introduce up to date meteorology trends. Where are the clouds moving? Okay, so we won't go for area of interest A because it's going to be clouds at that time. We go for area of interest B. And that's brought that percentage down to about 55%, which is still a very high percentage of waste, if you like, although it's a significant improvement. So this innovation, and I really think it's a substantial innovation, is to put a chip, which apparently weighs about 5 grams, on the satellite. And so if it's tasked with doing something, it's able to determine that the area that it's to do that something is covered in cloud and says, nope, not going to do that today. I'll go over here and I'll come back to it maybe another day. And that's going to mean that if you're ordering satellite imagery, there is no waste. And that does so much in terms of the use of the resource. And the scarce resource really is the satellite time. So 5 grams to be able to solve that big problem, I just think was incredible. And one of my friends, I suppose, Aubrey from CEDAR, when he was telling me about it, he was telling me that, they see this as something that's going to develop over time, where if you're looking for an analysis, say, of forestry in a particular area to see if there's a nutrition deficiency, that it will essentially give you your results. It's putting the image processing essentially where the action is, and it's leaving the scientists then to work on the data and work the data into information that the use case needs.
I realize we're sort of making guesses about what might or may not going to be happening in the future, but I think this is incredibly interesting. But when I talk to data scientists that are working with huge volumes of data and you ask them where they do the processing where the data is. So they're moving the algorithm to the data. And it seems to me that if you had some kind of onboard compute on these satellite platforms, that it would make a lot of sense, if it was possible, to move the algorithm to where the data is.
Absolutely. I agree. And it then means that the inefficiency, if you like, of download, upload, move from point A to point B in a workflow is at least ameliorated, if not removed.
I realize that that was a bit of sidetrack and we're jumping around in the conversation a little bit here. You mentioned SAR data right at the start of the conversation. This is something that you work with, and we've just been talking about the problems with cloud cover. Could you imagine carrying out the same kind of animal census, animal tracking using SAR data? Because I think the promise of synthetic aperture radar is that persistent monitoring, that we can image any time of the day and night and through lots of different weather. Would it be possible to carry out this kind of survey, animal survey, using that data, do you think?
It's something that we're going to do in phase 3 of the project that we're talking about now, the animal inventory, which is in its second phase. And sometimes, like one of the examples that gave somebody about, say, the standard method of determining whether there are cereals there or not is you analyze the infrared parts of the spectrum. And that will give you a different signature for barley, wheat, and oats, say the main types of cereal. And people will accept that. They'll say, okay, I know that shade of pink, if you like, is barley, and I know that shade of pink is wheat. But if you stop and think for a moment, you're not actually looking at barley. You're looking at something that represents barley to you. So if you take that piece of logic and then say, okay, we can't actually see the cows. We can't because the human eye doesn't allow us. But there's something in the parcel that gives you coherence with the presence of animals. And you can do that maybe by, say, a regular check of updating what you're getting versus what you have previously available with optical imagery. So we tell whether there's barley or wheat without actually seeing the barley or wheat. And we want to look and see, without actually being able to identify the animals, can they be detected using a coherence with what's known, correlation, if you like, with other data sets. It'd be an interesting one to look at. When we first looked at this, when we were approached to take it on as a project, we were a little bit more skeptical than we should have been. And we weren't sure at all that it was going to be as successful as it's turning out to be. So the thing about research is that you just don't know what you're going to find. That's really part of the excitement for us.
Absolutely. I mean, there's so many great examples of mistakes that have turned into incredible products out there as well, where people started and then just sort of stumbled their way through it and discovered something amazing.
Yes, yes, indeed. Right from penicillin, and I'm sure many before that. Yeah.
So a wee while ago, I saw an article, and it was an article about using a similar technique, I'm sure, as what you're doing, but they were using it to count elephants. And they mentioned in this article that these techniques have also been used to count whales. So it seems like this works in other domains. What's the next thing? Like, are there any animals that we can't count with this? Is there any like domains in terms of counting animals or ecology that this is definitely not the answer?
Well, I suppose for very small species, possibly no, unless they're habitat constrained. So if you find the habitat, then you've got some correlation that the species you're looking for might be there. So outside of that, if we can tell where sheep are with a good confidence level, any animal of a similar size can perhaps be detected, unless it has kind of a Darwinian camouflage that, say fits in with its surrounding environment so that it's safe from predators. That might obviously be a challenge, I guess.
So I can completely see it with an animal hiding in the forest, for example. That makes sense. It's difficult to see through tree cover. It sounds like it'd be really, really messy data to work with. Is what you're saying that, in theory, at least, this technique that you're developing will work, and it just sort of depends on, do we have the resolution that allows us to identify animals?
It is that, but if the animal has a colouring the same as its surrounding landscape for its own protection, then that's going to be a challenge to us. In what we're doing at the moment with cattle, we're taking in the animal and we're taking in the shadow. So it's a mix of the two things.
What do you get out of looking at the shadow? Is that just confirming that something is in the way of the sun, that there is an object there, or is there something else?
Well, it's giving you an idea of mass as well. So you know that it's not somebody has painted a picture of a cow on a two-dimensional picture of a cow on the ground. But I'm saying that facetiously. It's more information about the object of interest. It's another feature of the object.
So oftentimes when we talk about these kinds of algorithms, these kinds of analysis, people are really interested in the idea of scale. Does this scale? Can you use the same analysis to identify animals in New Zealand, for example, in my home country? Or would you have to adjust things slightly depending on where in the world that you're looking, assuming that the same data was available?
If the same data is available, if the topography is similar, which it is really in New Zealand, I think, in many parts, yes, it's very transportable. But also the fine tuning, if you like, or the calibration is probably a better word, of the workflow is relatively straightforward. So once the area of interest is identified, the species is identified, then the processing will depend on that context.
When you say topography, are you talking about the land cover? So the signature of the land cover, if that's similar, or are you talking about the actual elevation or the terrain in the landscape?
I'm talking really about the land covers. So, for example, I live in a very verdant country, the famous 40 shades of green in Ireland, which is a function of us getting rain every second day. But cattle are grazed around the world in far more arid terrains than we have. So the surrounding vegetation is going to look different. To us, it would look stressed, but in the context of somewhere in Africa, it's not a stress at all. It's just the way it is. So we would calibrate our workflow to take account of the difference in the setting, if you like, where we're going to carry out the inventory. And once that's done, then it's the same process.
So if I was a farmer and I knew this was going to happen and I wanted to cheat the system, I wanted to make it look like I had more livestock than what I actually had. What would I have to do? You mentioned before that you looked at shadows to get an idea of the three-dimensional structure of the object. So could I buy some plastic cows and put them out in the farm? Or what would I have to do to cheat?
Yes, you could buy some plastic cows and you could put them out on the farm, or inflatable cows and put them out on the farm. You'd face a number of challenges there. You'd want to be out pretty early in the morning moving them around. If they were inflatable, you'd want to make sure they're fairly well tethered if there's any chance of a high wind. So for animals which will naturally move, I would guess it's a pretty high maintenance solution.
I was just curious because we live in a world where the proof of location is becoming increasingly important. Location is sort of baked into lots of different things that we do. And if we think about the GNSS signals, for example, spoofing them causes a real problem for a lot of different critical pieces of infrastructure. And this is why we see things like authentication starting to be baked into some of the signals that are available. So I was just curious, like, how would we prove that these animals are where we think they are, or how could I disprove it? How could I cheat? What kind of safety features have you built into the system to make sure that I'm not cheating?
Well, more than one look indicates that whether movement has taken place or not. And if the animals are in the same spot that they were in a week ago, 2 days ago, or some time ago, well, then there's clearly a problem. And then the other thing is that any system like that does need invigilation. Say, for example, in an entirely different domain, we all fill in our taxes online and we fill them in on trust. But there's always that possibility, maybe that you might get an audit. So if you get an audit and you fail, then you're in big trouble. So generally, I've found in subsidy schemes, there's a high level of conformance and compliance that basically farmers are very honest people and they're doing their best to fill out quite complex application forms. And most of the errors that we would have seen or non-conformance are basically accidental errors. It's still the case, though, that any farmer can be audited and any of the processes that we carry out can be audited and generally are annually. So there's an invigilation required if there's, say, the payment of public funds, because public funds have to be corrected. But in the main, just coming back to it, if somebody had the plastic cows, it's an awful lot of plastic. It's not very kind to the environment, and they would have to move them around fairly frequently.
I appreciate you walking us through that. And I realize it sounds like an incredibly stupid question.
It's not, because, as somebody said to me a long time ago, anytime you have a scheme, you have to provide for the possibility you'll have schemers. So it was a very good question.
It's just that I've heard this example time and time again where people have thought that, oh, if we could just count all the cars in the Kmart parking lot or the Amazon parking lot or whatever parking lot, we could probably figure out a really good correlation between how many people are in that business and how that stock is going to perform in the future, kind of thing. So people are starting to bet money on these kinds of schemes. And I'm wondering, like, wow, if there's a lot of money at stake, if the game becomes how do we get more cars in the parking lot, somebody's going to figure out how to do it and just, well, here's some big plastic sheets. We can put them out each day. If that makes a difference, then let's do it.
You're right. On both counts, it would certainly game any system if you have an inanimate object that does not move frequently. And cars in lots, if somebody's, say, an office block and they park their car in the same designated spot every day, it's going to turn up every day. And so if you put a plastic one there or a blow-up car, it's going to have the same appearance. But one of the things about that type of work, say in forecasting commodities or the health of an economy on the basis of the number of containers entering or leaving a port, is that it's the additional data sets that you referred to earlier, Daniel, of that help to prove and disprove. So if you take any single data set and blindly follow it, regardless of what it is, I think that you're going to be error prone. So it's the other data sets you bring in to validate what you have, and your processes of validation, whether that be spot checking or whether that be using other pieces of data. Guess what? That Kmart car park has more Ford cars in it than Ford actually produced. So there's something wrong somewhere,
I love that idea of using other data to validate it. And we seem to live in a time too where we have an overwhelming amount of data. So surely we can find something to sort of prove or disprove our theories against. Speaking of data, if I come to you now and I say, look, I am really interested in monitoring all the cows in Denmark. I want to carry out this livestock inventory. Can you give me an idea, like, what is it going to take you? What are the requirements? Do we have to wait for 7, 8 sunny days? And what would the output of this kind of inventory look like? What would I get back?
If you had a vector line work shape of each field, we would tell you, you give us the field, we'll tell you whether or not there are animals there, the animal of interest to you, and how many of them we estimate to be there. So that would be typically the way this would operate. In relation to time, the time it takes, if there's one cloud-free day for an area the size of Denmark, the imagery would be captured in 1, possibly 2 days. So then it's a processing issue, and processing these days, happily with the way processing capability has gone, is a variable. Essentially, you can expand processing capability to meet the demand. So it depends also then on, is it just a simple inventory of 15 cows in that field, 30 cows in that field, no cows in the other field? Or do you want to know something else? Do you want to know by how many cows were in a particular area, a cadastre in Denmark? Do you want to know what the change was between this year and last year, or between seasons? Because that type of farming tends to be seasonal. The dairy industry is seasonal. Most milk is produced during the summer months. So it depends on really the question that you need to have answered.
Okay, so I'd really like to sort of broaden the horizon of this conversation just a little bit now. We just talked about cows in Denmark, counting them. You gave me an idea of what they would look like, how long it would take. Thank you very much for that. In terms of agriculture or monitoring natural resources, are there any other sort of standout use cases for this kind of technology?
There are many. An interesting one that I saw was monitoring the catching of tuna fishing and whether somebody was fishing illegally or not. So somebody has a license to fish to catch one standard net of tuna, which is basically a big net ring, swoops up the tuna and brings it back on shore. If somebody's fishing illegally, they'll have a second net. So it's possible to tell from satellite imagery whether the net is full or not by looking at its shape. If it's full, it's going to be oval. And if it's empty, it's going to be round. So you might think, okay, there's one net of fish extra. What's the big deal? But each one of those can be worth about $2.5 million. So somebody is fishing illegally, $2.5 million, damaging, I suppose, the stocks, not paying any taxes, and committing a whole load of environmental crimes. And satellite imagery helps there to detect that because you can see from space whether there's one, two, or possibly even three nets and whether they're full or empty. Another one that I came across outside of agriculture was radar imagery that we spoke about earlier, Daniel, is very good for discriminating the difference between ice and water. Two guys developed a system which they then subsequently sold to cruise ships. And people who go on cruises to the Arctic areas and the Antarctic want to see ice and they want to see big sheets. And this delivered in a prediction of where ice flows were going to move to in line with the cruise ship's course, which enabled the captain to say, okay, well, what we're going to do here is we're going to go 10 kilometers in this direction so everybody gets their photo up. And I thought that was just a brilliant idea, very simple, very well executed. So there are many, many use cases. And that's another thing I find so interesting about this work.
That's kind of fascinating because you would think that people would be wanting to avoid the ice, right? If you're on a ship, I think most of us have heard about the Titanic and what happened there. You'd think it'd be a good thing to avoid, but in this case, we're actually trying to get there.
Indeed. And, I'd share your opinion, but then there are people who like to roll down their windows in safari parks, so it has that function as well. They know what to avoid. And so they can cruise safely and they can cruise safely to allow people to take the photos that they wish to take and I suppose get the experience that they've probably paid quite a bit of money to get.
Would you mind telling us how long you've been in this industry again?
Since 1987. So whatever that works out at 35 years, is it? 35 years, yeah. And it's changed an awful lot, but I still find it very exciting, find it very interesting. And the great thing is I learn new things every day.
How do you do that? How do you keep up that enthusiasm? Because oftentimes we're told that we need to be lifetime learners. Do you have any advice for us in terms of sort of keeping up that enthusiasm? Because that could put a lot of people under pressure, or it could be seen as an opportunity. Oh, always learning something new, or damn, I've always got to keep learning something new.
Well, I suppose certainly I can see that's a challenge, but there's the old saying of find something you love doing and you'll never have to work a day in your life. And I've been really very fortunate because I have an interest in geography, a business that finds new things to do every day. And it's a great time in the industry with the explosion of processing power, the proliferation of new spacecraft, and then also new applications and young energy, which I think is great. Which when we talk about space, I know we're celebrating anniversaries of Yuri Gagarin, things that happened a long, long time ago, but it is still a very young industry and it's kind of exploding with growth and ideas, which is great.
One thing that really stuck out for me there was that finding new things to do. And I'm curious, what's driving that? Do you look at what's possible and then find new things to do based on that? Or is it sort of market driven where you see, oh, there's a need over here. You listen to the market and then find new things to do based on that? Because I think those two things are quite different.
They are, and that's a very good question. It's a mixture of the two. We work, I suppose, with governmental agencies mostly. Most of our clients are official bodies in some way. But we have a research arm that looks for new ideas, new applications, and we're very fortunate to have a good relationship with the European Space Agency, which is really very supportive of new ideas. And one of the things about that type of research is that no is an acceptable answer. If you look at something and it's just not possible, then that's an acceptable answer. It's been looked at, and the examination of the issue has value. And it means maybe that in 5 years' time, when somebody looks at it again, it's then possible. So that research is fundamental to who we are and what we want to be. And the European Space Agency support is vital for us to be able to continue. It's a great font of knowledge. They're very good at making sure that you kind of follow things in a logical fashion. They're a vital resource for us.
Most of us are selling something. I believe this. Most of us are marketers, whether we know it or not. Either we're selling our time, we're selling our skills, or maybe in your case, you're selling to another business. You've done your research, you have a new idea. How difficult is it to go out and sort of sell the idea, to market the idea, to make people understand what it is that you can do from them? Because I think when people hear things like machine learning, for example, or monitoring from space, like people like me go, wow, we could apply this everywhere. This is the answer. Everything else is finished. Like, pack up your tools. Now we've got this automated way of doing everything. But, there's a real education piece that needs to happen. What is that like? Is that difficult, or is it becoming easier with time?
We've developed a method of doing that over time. So I'll just divide up what we do into two areas. One is generally the fulfillment of a statutory obligation. And it has to be done by law. Things have to be checked, say like farmers growing crops and claiming subsidies. And then the other stuff is, here's a good idea we have. Would you be interested in looking at that? And our approach is kind of a customer service discovery. So we start off with basic questions, and we continue to ask those questions in a kind of a multiple choice environment, so that the potential client has a chance to think about what they might like and what they might not like. And then we're responding by saying what we think we can do and what we think we possibly can't do. And so you end up then with essentially a well-designed specification for what might or might not be done. And that served us very well, because quite often with technology that's not available in-house, that's being sourced into the house, the business, there's not an understanding of the limitations or the possibilities. And that's what we're there to do. Bring them on a journey.
Tom, I've just got one final question before I let you go. And that is, so you've been involved in this industry for quite some time. Are you that positive about it that you would recommend that I don't know if you have children or not, but if you did, would you recommend that they would be a part of this? Can you see a future in it for young people?
Well, I have a confession to make. My son joined the business 2.5 years ago. He's making good progress. It's an industry that has a long way to run in terms of innovation, excitement, possibilities. And really, ultimately, particularly when we look at environmental issues and food security and security for people, it has a role to play in keeping the world a little bit saner than it might otherwise be.
Just to follow up on that, is there any sort of particular skill set that you think people need to have in this industry today if they're going to be successful in it? I realize this depends greatly on what your role is in the industry. If you had to look at it over time, is there anything that's changed over time or that's becoming increasingly necessary?
Well, it's moving from being what was, I suppose, an artisanal science, where somebody had a project that involved acquiring imagery, downloading imagery, processing imagery, all on a worktop, interpreting the results, writing a report, delivering it back to the person who asked them the question. It's moving in the way that there's more of a continuous observation. It isn't a kind of discrete, spelled ETE, start and stop. And then the processing is happening at a much faster rate in a much more powerful environment. So those things have certainly changed. But what we look for really is an inquiring mind that can think logically. You might think that that's an attribute that somebody's born with or not. But basically, we feel it's something that we can all learn. And they're the two things which appear to be opposite to each other, because sometimes an inquiring mind seems to think of illogical things, but you have the idea and then you say, okay, let's test it, and to have the fun in that.
Tom, I've really enjoyed talking with you. It's been a really inspiring conversation. And I think on top of all your brilliance, you have this really disarming accent. So it's been great.
Daniel, thank you very much.
Can you just let the listeners know where they can go if they want to reach out to you, find out more about your work or connect with you?
Well, they'll find me on LinkedIn as Tom McHugh Icon. They'll find the Icon Group, or our website is www.iconicon.ie, and that will get us as well.
Thanks very much, Tom. Really enjoyed it.
Thank you, Daniel.
I really hope that you enjoyed that episode with Tom McHugh, CEO and founder of the Icon Group. I'll put a link to some of the places where you can find Tom in the show notes. You can reach out to him or find Icon if you're interested in continuing the conversation. I will also include a link to the journal article that I mentioned right at the start of this episode about using high-resolution satellite imagery and deep learning to count African elephants, if you're interested in learning more about that. And that's it for another episode of the Mapscaping Podcast. As always, you're more than welcome to reach out to me on social media. I'm most active on Twitter and LinkedIn. Just look for Mapscaping, host of Mapscaping Podcast, something like that. You'll find me. I'm hiding in plain sight. If email is your thing and you would rather send me an email, just send it to info@mapscaping.com. Send a thoughtful question and I will reply with a thoughtful response. Thank you so much for tuning in again this week. It's much appreciated. I'll be back again next week with another episode for you, and we'll talk then. Bye.